Number 1. The log base b of x times y is equal to the log base b of x plus the log base b of y. Now, the reason for that is this corresponds to the exponential rule that when you raise one power to another power, you add the exponents, right? So if this is b to the x times b to the y, that's equal to b to the x plus y. So it's the same rule, but it's the logarithmic version of this rule. So remember that the log represents the exponent themselves, the power. The log is the power. And so when you multiply your bases, you add your powers together. Okay. 2, similarly, log base b of x divided by y is log base b of x minus log base b of y. And that's the analogous version of b to the x divided by b to the y is equal to b to the x minus y, where we subtract powers. And then the third version is log base b of x to the nth power is n times log base b of x. And there's a couple of different ways to explain this one. First of all, this is analogous to the power rule that says if we raise b to the x to the n power, we get b times, or b to the x times n, where we multiply the exponents. But the other way to look at this is just rule 1 again. This is log base b of x to the n is equal to, back up here, is equal to log base b of x times x times x dot 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 times x, where this factor of x appears as n factors of x. And then using rule number 1 up here, which says that when I multiply 2 of these together, I can add the logarithms. This is log base b of x plus log base b of x plus dot 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 plus log base b of x, where there are now n terms, which means that this is log base b of x, and it occurs n times. So there's another little proof of where rule 3 comes from. So those are our basic logarithmic rules. Let's take a look at some examples. Now, it isn't all going to be fun and games and just using these rules. These rules are a means to an end, but we can try to simplify some of these things, or these expressions here. Let's take a look at some homework problems. Just for funsies, I'll knock out some even ones. Example. Simplify the following. Let's see here. Log base 2 of 128 over x squared plus 4. So we're going to do the best of our ability to simplify this. One thing that we can do is we can note that this is the log of a quotient, and we can use rule 2 here. And so this is log base 2 of 128 minus log base 2 of x squared plus 4. Now, there's not a lot we can do with that second expression, log base 2 of x squared plus 4, but 128 is actually a power of 2. see, 2 to the 5th is 32, 2 to the 6th is 64. This is 2 to the 7th power minus log base 2 of x squared plus 4. And this just becomes 7 minus log base 2 of x squared plus 4. And apparently, as far as the book is concerned, this is the simplified version of that expression. Maybe a little bit more simple. Now, this also happened to use our cancellation laws. I should probably put those up here. Let's see. Rule number, so cancellation laws. And although I already talked about it, I should probably talk about them again in this section, cancellation laws. So again, the cancellation, does cancellation have 2 L's in the middle of it? It looks weird. Cancellation. Where's my autocorrect? Cancellation law number 1 is log base b of b to the x power is equal to x. This is actually inverse properties. 2, b raised to the power of log base b of x is also equal to x. And so the general rule of thumb here is, if you have your bases matching in the exponential and in the logarithm, there's going to be some kind of cancellation. Whether or not it cancels out that easily is going to be another story. You got to use these exact forms. But we'll take a look at that in just a second. So let's take a look at another one here. What was that? Another example. Simplify. Log base 6 of 216 over x cubed times y, all raised to the 4th power. So there's a lot of notation going on here, and we're going to, well, you guys ever eat an elephant? You guys know how to eat an elephant? One bite at a time. Otherwise, you're going to choke, man. And I suggest starting with the trunk. Okay, so the first thing that we're going to do here is note that we have an exponent on the outside of our function. So we'll use rule number 3, the power rule, which means that we can bring that power down as a coefficient. That is log base b of x to the n is n times log base b of x. So this is 4 times log base 6 of 216. My 6's look like b's. Be careful. X cubed y. Then we can go ahead and use some parentheses here. We'll break this up even further using rule number 2, the quotient rule, which says that log base b of x over y is log base b of x minus log base b of y. So this is log base 6 of 216 minus log base 6 of x cubed times y. If I distribute the 4 here, I'll get 4 times log base 6 of 216 minus 4 times log base 6 of x cubed times y. 216 is a power of 6, man. Did you guys know that 216 is 6 cubed? So this is 4 log base 6 of 6 cubed. And this is minus 4 log base 6. I'm going to rewrite this as x cubed times y. So we can simplify this a little bit. This is 4 times log base 6 of 6 to the third power is just 3. That was a cancellation law. And what's important here is, even though x cubed has a power of 3, I cannot use the power rule. I cannot take this 3 and bring it down as a coefficient in front and multiply here, because y is not also cubed. This is a product first and foremost. So this is log base 6 of x cubed plus log base 6 of y. So not only did I use the cancellation law number 1, but I also used the product rule. So let's go back and give these names so I don't have to keep enumerating them. This is the product rule for logs. This is the quotient rule for logs. And this down here is the power rule for logs. 1, 2, and 3. And then our cancellation laws are there. So I'm also using the product rule. And then if we do a little bit of distribution, this is 12 minus 4 log base 6 of x cubed minus 4 log base 6 of y. And then finally, I can use the power rule one more time. This is 12 minus 4 times 3 log base 6 of x minus 4 log base 6 of y, where I'm using the power rule again on this expression to rewrite as this expression. And we have 12 minus 12 log base 6 of x minus 4 log base 6 of y. And that's it. That's the expanded form here. Okay. Let's do some more. Whoops. How do I redo that? I'm trying to use Procreate hand gestures and they're not working.